Among the strangest and most haunting theoretical objects ever proposed in the universe is the Gravistar, a silent predator of cosmic proportions. It emits no light, radiates no energy, and cannot be detected by any instrument known to science. Yet it may possess the terrifying power to annihilate an entire star system without leaving a trace. Unlike black holes, Gravastars don't consume matter through gravity. They simply erase everything around them through immense pressure differences in the fabric of spacetime itself. So, if Gravastars are real, is it possible we've seen one and never even known it? Gravastars have no singularity, no event horizon. Instead, they are cloaked in an ultra-thin shell thinner than a single atom, composed of exotic matter under extreme negative pressure, modeled through the Casimir effect between quantum vacuum fluctuations. Inside lies a vacuum zone filled with negative energy, a realm where not even matter, plasma, or neutrons can survive. It defies the physical principles established by the Standard Model. These are not just ideas, they are redefinitions of reality, forged at the edge of human imagination. Some scientists even speculate that the elusive dark matter we've been chasing for decades could in fact be made up of billions of tiny gravastars scattered throughout the cosmos. But what if the mystery goes even deeper? What if our entire universe is just the inner core of an unimaginably massive gravistar? Join us as we explore the Gravistar, a cosmic object unlike anything you've ever known, one that could rewrite everything we believe about modern physics. It doesn't need to emit light, it doesn't need to devour matter. Yet the Gravistar boldly challenges the very foundation of the black hole model, a model long accepted as a pillar of astrophysics. While black holes are elegant solutions to Einstein's field equations, they come bundled with two unresolved paradoxes: a singularity of infinite density and the irreversible loss of information, violations of the very principles of quantum mechanics. Gravastars emerged as a theoretical counter-argument to these conundrums. First proposed in 2001 by physicist Pavel Mazur and Emil Matola, the Gravistar model introduced a radically compact object without a singularity or an event horizon, yet capable of mimicking the gravitational field of a black hole. At its core, the Gravistar is a space-time structure divided into three regions: an outer shell of ordinary vacuum, a middle layer of ultra-dense matter under extreme pressure, and an innermost core of negative energy vacuum, akin to the mysterious nature of dark energy. The key lies in its elegant resolution of the singularity paradox. There is no point where density spirals toward infinity. Instead, there's a stable vacuum zone where negative pressure perfectly balances gravitational pull. Gravity no longer collapses matter into a mathematical breakdown, but is counteracted by quantum repulsion from negative energy. This equilibrium forms a stable configuration where Einstein's equations remain fully valid. This structural difference leads to a dramatic divergence in physical behavior. Gravastars have no event horizon, the point of no return that defines black holes. Without this boundary, information isn't lost forever. Quantum processes such as tunneling or gravitational interference may allow information to be recovered, preserving the core tenets of quantum theory. Gravitationally, a gravistar creates a field nearly identical to that of a black hole. From a distance, objects orbiting it would behave almost the same, making direct distinction incredibly difficult. But the difference may reveal itself in gravitational waves. Unlike the clean fade-out seen in black hole mergers, gravastars might produce faint echoes after the main signal, subtle reverberations that linger. A 2007 study by Chiarenti and Rizzola in Physical Review D proposed these echoes as a telltale signature. These non-classical gravitational fingerprints not only offer a theoretical basis to distinguish gravastars, they invite experimental validation. Advanced gravitational wave observatories like LIGO and Virgo are now sensitive enough to detect such anomalies. So far, no signal has definitively confirmed the existence of gravastars. Yet, just as crucial, no observation has conclusively ruled them out. Gravastars don't defy general relativity. They don't violate quantum mechanics. They simply fill the void between the two, where our most powerful theories fail to unite. Simple in geometry, ruthless in efficiency, and elusive in nature. The gravistar remains a ghostly contender in the cosmic data, a reminder that the universe may still hold secrets our equations have yet to decode. Unlike classical objects, whose outer shells serve as mechanical protection, the shell of a gravistar exists at the edge of physical extremes without violating a single known law of nature. This isn't a boundary made of matter in the traditional sense. It is the dividing line between two distinct phases of spacetime. On one side, the familiar gravitational field of classical physics. On the other, a vacuum filled with absolute negative energy. In the structure proposed by Mazur and Mottola in 2001, this shell has no defined surface in the Euclidean geometric sense, and yet it plays a clear physical role. A pressure wall that balances two opposing energy domains. In their model, the core mimics dark energy, while the shell establishes a pressure gradient that preserves the integrity of spacetime, preventing any material signal from ever crossing. Casimir theory, experimentally confirmed since 1948, provides the foundation for the existence of quantum negative pressure in boundary-limited vacuum environments. In the Gravistar configuration, this phenomenon is expanded conceptually, no longer a mere force between metal plates, but a gravitational compression born from the difference in quantum fluctuations inside and outside the core. Ordinary matter cannot survive here. All quantum states collapse, forming a boundary that nothing can penetrate. The Gravistar shell emits no light, it radiates no energy, it responds to no frequency in the electromagnetic spectrum. From radio waves to gamma rays, it is completely invisible. No telescope, no matter how powerful, can detect or pinpoint such a structure. It carries no distinct heat, no unique mass signature, and unless violently disturbed, it produces no gravitational waves. Dynamic simulations based on Einstein's field equations reveal that for the shell to remain stable, it must exist within a closed, curved spatial geometry. In this configuration, spacetime curvature balances gravitational pull with the quantum repulsion of negative energy. Stability isn't achieved through collision, but through pure geometric design. A manifestation of high-order Riemannian curvature and quantum energy conditions. Unlike a neutron star's surface or a planetary crust, the Gravistar shell exerts no local influence. Instead, it acts as an absolute boundary, a final horizon where classical physics no longer offers a definition for reflection, transmission, or interaction. Any measurement attempting to pass through loses coherence. Not because it's absorbed, but because the laws of nature simply stop working there. This shell isn't just a passive part of a larger object, it is the defining element. It marks the boundary between the observable universe and a realm of perfect stillness. A place where time, energy, and space cease to carry their conventional meaning. The Gravistar's impenetrable shell is more than just a boundary between two phases of matter. It is a doorway into a realm where our fundamental definitions of matter, energy, and time fall apart. There are no particles here, no plasma, not even neutrons. Within the entire volume of the core, no form of matter can remain stable. All that remains is a theoretical yet well-founded abstraction, a vacuum of negative energy. In the Gravistar's tri-layer structure, the central core isn't a solid mass. It is a hollow quantum volume, defined solely by negative energy density, a state inspired by the Casimir effect in narrow quantum boundary environments. Unlike ordinary vacuum, which fluctuates with virtual particles, the Gravistar's core suppresses all such fluctuations. The system collapses into the lowest possible energy state, a background so quiet, so absolute, that no physical phenomena can occur. In models of curved spacetime infused with negative energy, Riemann curvature doesn't converge toward a singularity. Instead, it spreads smoothly across space, forming an intrinsic hyperbolic geometry. A region of pure negative curvature, disconnected from the flat geometry beyond the shell. This signature arises naturally from Einstein's field equations when negative pressure becomes the controlling parameter. The result, a structure without a center, without boundaries, without singularity, yet entirely stable. Within the core, no physical signal can propagate. Light cannot travel. There's no medium to carry it. Gravitational waves cannot form. There's no local inertia to define them. Even physical constants like Planck's constant or the speed of light lose their meaning. In such conditions, the standard model of particle physics dissolves. And the very notion of quantum structure becomes irrelevant. Quantum gravity theory, in its attempt to merge quantum mechanics with curved space-time, has proposed mathematical frameworks like loop quantum gravity or causal set theory, where space is described in discrete units. The Gravistar core is a pure geometric realization of that state. No continuous space, no measurable dimensions, no distinction between points and regions. Here, every physical representation collapses into bare geometry. A foundation existing independently of any measurable quantity. Nothing escapes from this core, not because it's trapped like inside a black hole, but because within it the concept of information itself ceases to exist. All markers of time, all physical entities, and all instruments of measurement are erased by the radical nature of negative energy. Gravastars don't need to consume to conceal. Their deepest region holds nothing to hide. Because it does not exist in any observable sense, with time locally frozen at its boundary and no information able to escape from within. The Gravistar has already proven itself to be a self-contained entity, structurally and physically isolated. But its influence doesn't stop at the shell or the core. Gravastars may have the power to affect entire star systems from a distance, without direct contact, without emitting energy. This form of interaction defies classical gravitational models and raises an unsettling question. How can an object that doesn't shine, doesn't consume matter like a black hole, destroy a stellar system? The answer lies in the pressure fields and warped spacetime surrounding a gravistar. Unlike the concentrated gravitational pull of a black hole, a gravistar generates a non-linear zone of influence. Where space-time is distorted not by gravity in the classical sense, but through gradients of quantum pressure. There's no accretion flow, no X-rays, no heat, no collisions. Destruction happens in silence, as if the structure of affected matter decays from within. When a stellar system, say, a planet orbiting its host star, enters this gravistar field, nothing appears amiss. There's no temperature spike, no spectral shift, no change in radiation. But according to curved space-time models with negative energy, once a certain threshold is reached, the internal energy state of matter becomes unstable. Atomic bonds begin to weaken. Nuclear stability breaks down, disrupted by localized distortions in space-time geometry. In quantum gravity models like effective field theory, extreme negative pressure may cause a breakdown in the very fabric of particles. not through collisions, but through foundational instability. Scientists have long speculated about vacuum decay. A sudden collapse of false vacuum into true vacuum. Triggering a massive destabilization of a previously stable energy field. With its negative energy core and ultra-pressurized shell, the Gravistar may act as a catalyst for such a collapse on a macroscopic scale. Once instability crosses a critical point, particles in the surrounding zone may lose their quantum cohesion and fall into non-radiative decay. No explosion, no trace, no thermal footprint. Telescopes like the Sloan Digital Sky Survey, Gaia.Pan-STARRS have observed vast regions of near-empty space. Voids that defy typical galaxy formation models. Some of these regions don't align with gravitational rupture zones. Show no signs of galactic collisions and emit no light in any known spectral band. Could these be the remnants of encounters with Gravastars, entities that pass without impact? But erase matter entirely through an unknown mechanism? Unlike black holes, which leave clear signatures through accretion disk. Gravastars leave nothing of the sort. They don't heat matter, don't produce radio waves, and don't emit strong gravitational waves. Unless physically disturbed. Their influence, driven by negative pressure, causes matter to disappear silently. A localized annihilation that can only be inferred by the absence it leaves behind. This mechanism turns the Gravistar into a destroyer that never touches its victim, never draws it in. Instead, it alters the surrounding quantum conditions. Causing nearby structures to collapse from within in an irreversible process. And it is this very silence that makes Gravastars so extraordinarily difficult to detect. No explosion, no flash of light, no shock wave. When a Gravistar passes through, it leaves behind not debris, but void. Perfect, absolute, inexplicable emptiness that no classical law of physics can account for. The absolute silence left behind when a Gravistar sweeps through a star system may not only signal a new kind of cosmic annihilation, it may also point to something even more profound. What if these non-luminous, non-radiating, and electromagnetically invisible structures are the very key to solving the century-old mystery of dark matter? Dark matter, as defined by observation, is a type of matter that doesn't interact electromagnetically. It doesn't absorb, reflect, or emit light. Everything we know about it comes from the gravitational effects it exerts on surrounding luminous objects. But what if dark matter isn't a new kind of particle, but instead real, stable, isolated, and completely non-interacting entities like gravastars. Gravastars, with no emission of light or heat. Match the behavioral profile of dark matter almost perfectly. According to a 2012 study published in Classical and Quantum Gravity, gravastars could form not only from the collapse of massive stars, but also during the earliest fractions of a second after the Big Bang, right after the Planck time. These primordial gravastars would be far smaller than stars. Yet still massive enough to exert significant local gravitational influence. Could the universe be filled with billions of these primordial gravastars, not as large as black holes, not radiating or interacting, but quietly scattered throughout galaxies? Microlensing surveys such as OGLE and MACHO have already detected anomalous signals that couldn't be explained by planets. Dwarf stars or black holes. These anomalies seem more consistent with high-density, non-luminous objects. The exact profile gravastars would exhibit. The Gravistar model also holds a major advantage over hypothetical particles like WIMPs or actions. It doesn't require expanding the standard model. It doesn't break energy conservation, and it doesn't rely on introducing new interactions. The entire behavior of gravastars can be described using established principles, space-time geometry and quantum negative pressure. foundations already accepted in modern theoretical physics. Not all forms of dark matter need to hide inside a particle collider. Perhaps what we're searching for isn't trapped in a lab, but quietly drifting through billions of light years, invisible. Undetectable by conventional means, yet holding entire galaxies together. The Gravistar, through its silence and absolute stability, is emerging as one of the clearest geometric candidates for the kind of matter that shapes the universe, yet remains unseen by all. If gravastars are candidates for dark matter, an even deeper layer of the hypothesis begins to unfold. What if gravastars aren't just embedded within the universe? What if the universe itself is a gravistar? On a cosmological scale, this idea isn't just a piece of speculative fiction. It has been proposed through interdisciplinary research between quantum gravity and cosmology, fields where the line between particles and space-time begins to blur. This model suggests that during the gravitational collapse of an extremely massive object, such as a supermassive black hole, instead of forming a singularity, the internal physics give rise to a stable region of spacetime. That region becomes, in essence, a self-contained baby universe with its own internal structure. The Gravistar's shell acts as a boundary beyond which nothing can escape. Corresponding to the edge of the universe, we observe expanding. A 2006 paper published in Physics Letters B by Eason and Brandenburger proposed that dark energy, the mysterious force driving the universe's accelerated expansion, could be a direct result of negative energy conditions inside a cosmological gravistar. In this picture, everything we observe, galaxies, the cosmic microwave background, the large-scale cosmic web, is entirely contained within the core of a much larger structure. Sealed off by an unobservable shell. From a quantum perspective, this idea resonates with simulation-based models like the ADS/CFT correspondence. Where a higher dimensional space can be fully described by its boundary theory. In the Gravistar scenario, that boundary is the shell itself, a region of extreme negative pressure that creates a strong enough gravitational condition to sustain an internal universe. Complete with its own physical constants and initial conditions. The uniform expansion of the cosmos, its large-scale isotropy and homogeneity, and the existence of a cosmic observational limit all align remarkably well with this interpretation. Our inability to observe beyond the edge of the universe might not be due to technological limits, but because space-time itself ends there, just as nothing can pass beyond the shell of a gravistar. The hypothesis that the universe is a gravistar does not reject existing physical laws. On the contrary, it offers a geometric framework that unites quantum mechanics, general relativity, and cosmology under a single structural paradigm. In this model, space-time, energy, and information are not things that exist outside the universe. But are held within the heart of one self-contained, stable, non-luminous, non-interacting entity, silently floating in a greater reality that remains forever out of reach. while traditional cosmological models strive to expand observational boundaries and hunt for fundamental particles. The Gravistar places all those efforts in a paradoxical light, an object that does not emit, does not reflect, leaves no trace, and offers no clear distinction between what exists and what does not. It doesn't need to break any physical law. Yet it has the potential to upend our entire foundation of understanding. In experimental cosmology, every major discovery has come through light. Whether in the form of microwave background radiation, gamma ray bursts, or visible spectra. The Gravistar stands outside this entire system. Its interaction with the surrounding environment occurs solely through spacetime geometry. Something that cannot be directly measured with conventional instruments. The only clues lie in empty voids within galaxies. In the odd motions of celestial objects. Or in subtle anomalies in gravitational wave signals. These are indirect hints, compelling, yet not conclusive. And that's precisely what makes the Gravistar so extraordinary. It remains theoretically possible, mathematically consistent, dynamically stable, and yet completely beyond confirmation by any current means of observation. gravistar requires no energy to persist. It does not decay, it does not lose mass over time. In a universe that is expanding and slowly diffusing its energy, a motionless, immutable, and non-interacting object like a gravistar represents the ultimate antithesis. Every component of a gravistar, the shell of negative pressure, the dark energy core, the timeless boundary, all exist within theoretical frameworks grounded in established physics. They align with principles from quantum mechanics and general relativity, and require no imaginary constructs to exist. They don't conflict with quantum field models, nor do they violate the structure of Einstein's equations. And yet, it is this very perfection that makes the gravistar so deeply unsettling. Not because it strikes, but because it quietly rewrites the way we define reality itself. Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.